Now see in this case what they're saying here. Have same kinetic energy, same breaking force now. Now tell me now which one will come to rest? Which one will come to rest in shorter time? Shorter time or shorter distance? Yeah, shorter time only here. So shorter time case we use the impulse relations we use. Yeah, tell me now impulse relation. Yes, now impulse is equal to what? Tell me now here. F into T, which is equal to change in momentum delta P. So minus na retarding force. Now this is m into final velocity minus initial velocity. So this is minus F into T, which is equal to what we can say final velocity 0. So that is minus mu. Then we'll come it as F into T, which is equal to m into u na. Yeah, they are asking to find what? Tell me now here. Same. So we can write F into T, which I can write it as a P, I can say na. Here they are saying the kinetic energy same, so we should convert the P in terms of kinetic energy. Yes, K is equal to P square by 2m. So from this P is equal to what? Tell me now. Square root of 2m into K na. So we can use this relation now. So tell me now F into T will come to be what now? So that is F into T, which will come to be a, that is root 2m into Ke. Now T value we need na? T value. T is equal to what we can say now here? That is 2m Ke by F. Now we need to see which terms are same now. See which are same now here. Kinetic energy is same and force is also same. Then T proportional to what? Tell me now here. Yes, T is proportional to root m. That means if the mass is high, time is also high na. Mass is high means time is high. We need the shorter time we need. That means mass must be low. And which has a less mass? Car has a less mass. So that means in this case, which will come to rest in shorter time? Car. Right. Car will come to rest. Car will come to rest in shorter time. Right.